Hi, good day, everyone. In this video, I'm going to review or analyze the Biochem 423 test questions. And the decision to do this is basically based on the fact that I felt it was too late for me to release the results for you. And in addition to that, I felt this video will help you better, being the fact that when you have your test script and you discover you felt in some of the questions, it will be very difficult for you to exactly know where the problem is. But reviewing the questions with me and telling you what I'm expecting you to do will guide you more. And in case when a similar questions comes around or any questions, you will know how you should attempt my question or what are the possible things that I'm actually expecting from you. So I will go through all the questions and then explain what I'm expecting from you so that at least when you are attempting my question next time, you should be able to be precise and go straight to the point without beating around the bush. In most cases, you will see that some of you will start giving history before they will finally say one or two things about the question. And sometimes even they get carried away with the history, they get lost. You see somebody narrating, but when it comes to the point where the answer will come, now someone would just be so yes, okay. Sorry. So you will see somebody being too economical with the points. And this is the point where you're supposed to see what is expected of you to see. So please, you have to not take note of this kind of things. The first question says, provide a pharmacokinetic explanation why alcoholics can consume more alcohol with fewer side effects than the occasional drinkers. Of course, this question was attempted by few, everybody, quite a number of you attempted the questions, but just a very few of you were able to hit the nail. Okay. This question is all about the fact that these enzymes that are involved in the generally, not even the only cytochrome P450 monoxygenases, all the enzymes, including the transporters, are inducible in nature. So somebody who is exposed to these things, to these xenobiotics, to a particular xenobiotics, those enzymes, those transporters, responsible for the synthesis or metabolism of this xenobiotic will definitely be induced. Therefore, the expiration level over time, because of the continuous exposure, you will have high concentration of those substances in the system of that individual. So even when that individual takes alcohol or take that xenobiotic, the body can easily take care of it and get rid of it. But somebody who is taken for the first time or take today after a long period of time, the enzymes are not fully induced. And of course, the concentration will be high to the system and the system will be clearing it gradually. But the longer it stays in the system, then the more rich, of course, in toxicity. And this is basically the concept I'm expecting from you. The next question says, xenobiotics are structurally diverse. Briefly explain how their metabolism through phase 1 to phase 3 was made possible. This is as simple as considering the fact that we talked about some properties also. These are phase 1, phase 2, and phase 3 enzymes and transporters. We say they have a large number of isomers. You have this particular enzyme, and it has its own isoform. And you discover that this enzyme, one enzyme can catalyze quite a number of substrates. We mentioned that. Quite a similar structure substrate. Then if this particular enzyme E was able to metabolize about 10 to 20 structures, then the next to it, which is an isoform of it, will now metabolize something similar to that, around 20, but a bit different structurally with those ones metabolized by the other isoform. Like this. So before you know, you will have these enzymes being able to metabolize a broad spectrum of structurally unrelated compounds. So they are very versatile biocatalysts. And another thing also, there is an overlapping substrate specificity, where you can have this particular substrate being metabolized by this enzyme. And another enzyme also, which is same cytochrome E450 monooxygenase, can also metabolize that enzyme. So this is the diversity of this enzyme. So even when you have a structure, xenobiotics, that you don't know where it is coming from, the body never know, never expected, you just encounter it, you inhale it, you ingest it, the body have those enzymes that are very broad with respect to specificity. I know you talked about enzyme specificity, there is a specific enzymes that have a broad specificity. So those classes of enzymes are the ones that metabolize xenobiotics. And this particular property of large number of isoform, overlapping substrate specificity, made them to be a very versatile biocatalyst. And this is basically in summary. All these things I'm saying, like repeating myself, you can say it in 1 or 2, 3 sentences if you like. The next question 3, which says, in brief, describe how enzyme induction and inhibition in xenobiotic metabolism influence drug efficacy, toxicity, and potential drug introduction. So one important thing you all know, that enzyme induction, of course, causes an increase in the expression of those enzymes. You can take a drug, or you can take a substance that will induce an enzyme. When it induces the enzyme that is involved or responsible in metabolizing a particular drug, it will lead to metabolism, quick or faster metabolism of that substance. And the faster that substance gets rid out of the body, cleared out of the body, the higher the clearance rate, then the less the efficacy, and hence can lead to treatment failure. But what happens is inhibition, you're taking a drug and now you take another substance which inhibit the enzyme that is responsible in metabolizing that, meaning that the drug you've taken will be metabolized very slowly because the enzyme that it is responsible is inhibited. So it's very slowly, so it can accumulate over a long period, and that they will elongate or enhance the efficacy because the activity of the drug gradually manifested. But because it accumulates for a longer period of time, it can force someone to toxicity risks. So also in the case of drug interaction, this is the same thing that happened. User can lower the effectiveness of co-administered drug, or inhibitor can cause a drug accumulation and adverse effects. So the 2 points are actually similar, but you can explain it in a few terms. So I also gave this for you to fill, and this is just a very simple, even though some of you went ahead and just keep on saying the same thing, somebody would just say, oh, I know OH is there, so you just put OH all through. Someone will just say, oh, NH2 is there, you just put NH2 all through without it. By looking at it, that person doesn't actually know he gets. But by the way, yeah, these are the just things you're expected to do. I'm sure this one is not. Also, this table actually have quite a number of majority of you because it's carried marks that a lot of you were able to. get something from first out of it. So this is basically what I'm expecting from you. So please, when you are attempting my questions, but you should know how to be brief and avoid giving history. I wish you a great success in your upcoming examination. Thank you.